This is our third video on graphing polynomial functions. Here's our function. We're going to set it equal to 0, solve it by factoring out the greatest common factor, which is negative x squared. And by doing that, we're going to end up with this binomial x squared minus 4, which is the difference of two squares, and that factors further into this. So here's our three factors that we will set each one equal to 0. Set that one equal to 0, that one, and solve. And we get these three roots, 0, negative 2, and 2. So 0, negative 2, and 2. 0 has multiplicity 2. That's an even number. That means this is going to bounce at 0. It's going to cross at those other zeros, but it's going to bounce at 0. Is there symmetry? Yes, finally we see one that has symmetry. This is an even function. It has y-axis symmetry. That means that the picture should look identical on the left side of the y-axis as it does on the right side. And you'll see that happen once we do our t-chart. How do I know it's an even function? Well, one shortcut way is the fact that I do have both powers being even. But the other is to look at the definition. The definition of even is that f of x equals f of negative x. And if you put a negative x in for each of these x's, and raise them to this even power, it becomes the same function. So this is even, has y-axis symmetry. The end behavior, because this is even and it has a negative coefficient, we know that this is going to fall left and fall right. So it's falling on both sides. The y-intercept, put 0 in, and we're going to get 0, 0. Which again doesn't help us any because we had 0 as one of our zeros, so we knew it crossed right there. So the maximum number of turnarounds, because this is x to the 4th, the maximum number of turnarounds is 3. So with this picture and this information, knowing that it's going to turn around at most 3 times, and it's going to drop off here, the only way it's going to get from here to here is going to be to come up and come back down, and bounce right there, go back up, and that's going to be what our graph looks like. What we're not sure of entirely is how high this goes. So we're going to pick a number between 0 and negative 2, which is negative 1, and pick a number between 0 and positive 2, which is positive 1. Because this has y-axis symmetry, these numbers should be the same. And when I plug negative 1 in, I get 3. And just to check, when I plug 1 in, I get 3. That just verifies that I really do have y-axis symmetry. So if I erase these little dotted lines right here and put the graph back, then over 1 up 3, over negative 1 up 3, and it looks kind of like this. Now the thing I don't know for sure, and I've mentioned this before, is this the actual highest point we have? We don't know unless we pick some other numbers, and I don't want to do 1.1, 1.2, etc. But this is the best we can do with the information we have at hand. But just to show you, here's my 1, 3. It was not the highest, so the graph that we got was a little bit inaccurate. All right, this next one is already factored for you, so that all we have to do is set it equal to 0, and set each piece equal to 0, and then solve. So we end up with x equals 0, x equals negative 2, and x equals negative 1. There are some multiplicity issues. Because this is an odd number, then we know we have multiplicity 3 on root 0. So an odd multiplicity means it's going to cross with a little bit of wiggle. This one, because of the power of 2, that's an even multiplicity, so 2 is going to bounce. So we have a dotted 0, negative 1, negative 2. This is going to be hard to see on this graph. We'll do the best we can. Is there symmetry? No. If you put a negative x in here and square this, it's not the same as this right here. Or even here. If you put a negative x right here, negative x plus 1 and x plus 1 are not the same. It's going to change the function. So there is no symmetry. End behavior. We got to do a little work to figure out the end behavior. We don't have to FOIL this whole thing out. Whatever happens with the foiling here, that's going to be x squared in the front. It's being multiplied by that x cubed times an x. That means this is x to the 6th. It is a positive x to the 6th, which means we're looking at an even power and a positive coefficient. So this thing is going to rise, rise. We've just got to figure out what's happening in between here. The y-intercept is 0, 0. We've already got our 0 graph, so that's not going to help us any. The maximum number of turnarounds, because this is x to the 6th, the maximum of turnarounds is 5. So let's figure out what's going to happen here. Between 0 and -1, we can do -0.5. And between -1 and -2, we can do -1.5. So plugging it into the calculator, I'm going to get rounded decimal of -0.14 for this one, and 0.42 for the -1.5. So this is not going to come out nice and neat, but we'll do the best that we can. So at -0.5, it's just down a teeny bit. And at -1.5, it's up almost halfway. Now put that together with the fact that we know that at 0, it's going to cross. See, it's going to cross there. But at -2, it's going to bounce. So it has to come down here, bounce off of here, come back up, turn around, and come through and go. So it's just got this little wiggle through here. Take a look at the real graph right there. Looks about like what I had. You can barely see right here where that did dip below the axis.